guys want to say hi to Veronica? All right, here we go. Maybe she has green PJs at home. Who knows? All right. 11.5, quiet please. 11.5, multiplying and dividing radicals. And we need to do both today. And we'll start off with multiplying radicals. So you've got part of the rule there in front of you, the square root of A times the square root of B. Now, I will tell you this. The index, the kind of root it is, this is a square root. So what's the index, though it's not shown? Say it if you know it. 2. It's a 2, it's not shown. They have to match to be able to multiply. You can't multiply a square root times a cube root. It won't work. You can't multiply a cube root times a fifth root. The indexes have to match. Here they do, and we're good to go. Square roots times square roots, cube root times cube root, etc., etc., etc. How do you multiply them? It's very, very easy. You simply multiply the radicands. Oops, that should be my red. So the new radicand is going to be the A in the bottom times, and I'm going to go to my green here, the B in the bottom. So 2 radicals become 1, and the radicand becomes A times B, whatever that would be. If A were a 2 and B were a 3, we're going to end up with the square root of 6. It's pretty easy. You multiply the radicands. That's all that's involved. That's the situation. That is the rule. You're going to multiply the radicands. So, just do a few here in this first one. There's my radical sign. And just to be clear here, we won't do this very long. We'll start to do this in our head. But we're simply multiplying the radicands, right? Square root of 3 times square root of 7. And we end up with the square root of 3 times 7 or the square root of 21, right? And that's our answer. Pretty simplistic. We all know 3 times 7 is 21. We just have to know that you multiply the radicands. That's easy. We can do that. You can do that. All right, so that's the idea, and that's what we're doing on these. We're simply multiplying the radicands. So again, on B, our radicand of 5. John, can you get our door for us? Times our radicand of 11. And I'm going to go out to the right. Usually I like to work below, but I didn't leave you guys a bunch of room, so we'll go out to the right on this. And we're going to end up with square root of 55, right? So, look at C. Surely we have no earthly idea how to do C. We didn't discuss 3 things, and of course, math's totally unorderly, and therefore we have no hope, but see what you can do. See if you can solve C. You know, we never talked about it. I'm sure it's impossible, and I'm sure you're never going to get it, and it's completely too hard because it's math, but see what you can do. All right, and obviously I see a lot of you guys doing this step here, and which makes perfect sense, right? You're just going to multiply up. That first one was a 2. Right, you're just going to multiply the radicands together. And where do we end up with, what, 30? Square root of 30? Piece of cake, no problem. Jordan. What do you mean, do you have to actually do this? Do you have to get a decimal answer? Is that what you're asking? If it's something you can take the square root of at the end, you would go ahead and take the square root of it. That's really another topic that we're going to talk about here, I believe, either the next time class meets or the time after that. Okay? But yeah, for right now, if it was something like square root of 9, you would finish it off with 3, or square root of 16, you would call 4, etc. All right, so, okay, well, I take it back. I should have looked on my notes. Really, the next topic comes right now. All right, simplifying radicals. Simplifying radicals. Technically, this is the way to do it. We're going to learn a shortcut in a minute, but typically or technically, you want to split them up into parts you can take the root of. I should have looked at my notes, Jordan, because really we're going to deal with it right here. And really a little bit less than what you thought. Okay, so here's the original. You don't need to circle it. I'm trying to get you to focus on where I'm looking, okay, and what I'm thinking of. Excuse me. We've got a square root of 40. Go ahead and take your calculators out, punch in 40, and hit your square root button. You're going to get 5 point something, 6 point something. 6 point what? 3. Okay. And it goes on, right? You get a round off, 6.3, whatever, and change. We don't like round offs. We like exact answers. Yet we can simplify this to a more simplistic answer. By really, listen now, we're going to use the multiplication rule in reverse. So let me show you back to the top. Don't write this in your notes, but look, didn't we take two things and put them together into one, right? That's multiplying. What we want to do now is take one thing and split it back up into two. You might say, why? Because it's to our advantage, if it's to our advantage. And again, we're going to learn to do this without actually technically splitting it up, and I'll show you why or how in a moment. But just hang in there. All right, so let's look at our problem here. If I can get that 40 to go away. Okay. So let's look at our problem. We've got the square root of 40. Now, I've already partially split it up. I'm going backwards. I'm unmultiplying. So if that first radicand had a 4 in it, what must the second radicand have? 10, exactly, right? Because a 40 is a 4 times a 10. So I unmultiplied it. I could have chosen 2 and 20, right? I could have. I could have chosen 5 and 8. But 4 and 10 is the best choice because everybody, what's the square root of 4? 2. And remember, 2 is the principal root of 4. And now we end up with 2 times the square root of 10. And that's a simplified form. Whatever you take the root of ends up being a multiplier of what's left. Okay, take your same calculator, punch in 2, hit your multiplication button, then punch in square root of 10 and hit equals. And if your calculator allows you to do it in that order, you should get the exact same number as the square root of 40, right? It's the exact same number. Again, if you punch it in the right way and your calculator accepts it. If not, do the square root of 10 first, get the answer, and multiply that times 2. So again, calculators are a little bit different in the way you input your data. By the way, if anybody doesn't have their calculator with them today, if you'll please stand up. Anybody like that? Everybody's got theirs? Good, because again, you need to figure out your calculator. So that's the exact same value in simplified form. You can kind of think of it as reducing a fraction. I mean, we're getting it in a more simplistic form, and there's value to that. You know, everything we do in math right now is for the bigger picture. Really, in reality, it's all about equations and functions. And we're learning pieces so that later we can put it together and solve equations and functions. Okay, so that's the concept. Split it up into things you can take the root of. So look at B. And what would I want to split this up into? And this one's kind of simple because there's not a lot of choices. Adam? Not 5 and 8, because that won't work. Okay, 5 and 9. All right, I'm going to put the 9 first in red. The one we can take the root of. And I'm going to put the 5 in the back in green. So go ahead and finish it. What does this simplify into? Well, the square root of 9 means what number times itself twice is a 9. That's a 3. And you still have the square root of 5. A number in front of a radical is multiplication. Just like a number in front of a variable is multiplication. All right? There's nothing in between. So 3 times the square root of 5. Hey, that's not hard, right? That's doable. All right, number 3. Remember, the index of a square root is, say it class if you know it, 2. And what does that mean? What number times itself twice equals the radicand? Or is a factor of the radicand? Or a factor of the radicand. So on this next thing, we're going to save time of splitting it up, because we know that works. All right, so take a look at A here. Let me get this up. Well, it's about as high as I can get it. Take a look at A. We've got the square root of 56 right here. Here's the concept. I can go ahead and split it up into 2 radicals if I want. Or I can simply start factoring the radicand. 56. Now, I don't know about you, but when I see 56, my brain automatically says 7 times 8. Does yours? I'm doing a factor tree right now, right? We've done factor trees. Now, remember, everything I'm doing right now is located where? Underneath the radical sign, right? It's part of the radicand. And can we take the square root of 7? No. Can we take the square root of 8? No. No. However, if I further factor the 8 into a 2 times 4, and again, remember, I always cross off a number once we factor it, is there something now in that denominator we can take the square root of? There is. I can take the square root of that 4, can I? Class, square root of 4 is 2. So I'm going to come up here. I have a 2. It's now out, right? It's free. It's been liberated. All right? It's out from under the radical sign. And what would be left inside? Square root of, what's everything left in, right? 14, right? 7 times 2. You got a 14 left inside. So we end up with 2 times the square root of 14. So let me pause for a moment. We could have done this. If we'd have thought through, we could have made this the square root of 4 times the square root of 14. But I don't know about you. I wasn't thinking of 4 and 14 when I saw 56. Were you? I wasn't. But by factoring, I'll find those factors that are the same. And sometimes it's in the form of a 4, and sometimes it's in a different form. So let's do another one. So here I am at square root of 98. Now in this one, I immediately think of 2 and 49. I don't know what you think of. That's my brain. Did you have to go 2 and 49? No. But now we're good to go, aren't we? So you look at that and what are you seeing? Devin, what are you seeing? Exactly. And we all know the square root of 49 is 7. Whatever you take the root of comes out as a multiplier. What's left in? Square root of 2, right? And remember, it's the radicand. So square root of 2 is left. We end up with 7 times the square root of 2. That's the simplified form. Now look, this is an exact value. That's good. We want exact values. So look, real life is like this. You do a calculation so you can put it into another formula to get another calculation, so you can stick it in another formula to get another calculation, so you can stick it in another formula to get another calculation. That's real life. When we went to the moon, assuming we actually went to the moon, when we went to the moon in the 60s, that's what they did. Calculation to a calculation to a calculation to a calculation. Do we want to round off that then goes into a formula that gets rounded off, that then goes into a formula that gets rounded off, that then goes to a formula that gets rounded off? Absolutely not. Because every time you round off, you're getting a little further away from the actual, definite, precise answer. And we want to deal with exact values as much as we can, which is why we leave it in this kind of a form, 7 times the square root. It's an exact answer instead of a decimal round off. Okay, so let's take a look at the last example here in this set. So now we have a multiplication problem. So now we're going to do this, but you know what? I'm not going to write 60. I'm not. You can if you're a bum, but it's the exact same concept as R-bum. You guys remember R-bum? Reduce before you multiply. How do we reduce fractions? By factoring, right? How do you simplify radicals? By factoring. So why should I multiply? I'd have to turn right back around and unmultiply. That doesn't make any sense. So I'm just going to leave it 6 times 10. And I'll show you a shortcut in a moment. So now let's look at our 6. Let me be in red here for the 6. We all agree a 6 is a 2 times 3, right? And we all know a 10 is a 2 times 5. Anybody see anything you can take the root of? You don't? Hold on a second, please. Let me go back to the definition here. Everybody look at number 3. Let's read it again. Remember, the index of a square root is 2, meaning, watch now, what number times itself twice equals the radicand or is a factor of the radicand? So we're looking for 2 of any number. Do you see 2 of any number? I have 2 2's. What's the square root of a 2 times 2? No. What's the square root of a 2 times 2? What's the square root of a 7 times 7? What's the square root of 11 times 11? What's the square root of 83 times 83? What's the square root of x times x? Exactly. Square root, what times itself twice? If there's 2 of them, the root is it, what it is. So the square root of that 2 times 2 is a 2, and I'm going to cross those out because I took the root of it. What's left inside? Square root of 15, and that's our simplification, 2 times the square root of 15. Now, I will tell you this. I'm fine with this. We do this in Algebra 1. We'll really do the simplification right here before ever putting it into 1 because we know it's the same thing. And we'll do this, 2 times 3, 2 times 5, and we'll do it right here, catch the 2 2's and the 15, and save a little step. Either way is okay with me, just be careful. All right, let's go to our next page here. What are we, 11.5, page 2? All right, optimize, reduce a little, back to the top. Let's get a shade. Okay, let's divide now. So that's multiplication. All right, division's pretty easy, makes sense. So if you have the square root, and look, our radicand is a, what kind of thing is the radicand? It's a fraction. The radicand is a fraction. What would make sense? Well, does this make sense? What about this? Come on, pens, give me my blue. How about the square root of the numerator divided by the square root of the denominator? That's how these go. You can split it up. If you have the square root of a fraction, or the cube root of a fraction, or the fourth root of a fraction, it's the root of the numerator divided by the root of the denominator. Kind of makes sense. You do have to remember that, though. But you get to split it up. Square root of A divided by square root of B. So now you come across a problem like this, square root of 81 over 4. Huh? But you say, no, wait a minute. That rule is the square root of the numerator over the square root of the denominator, right? So it's going to be the square root of 81 over the square root of 4. And again, I always prefer to go down, but sometimes in some of these problems, across is a little easier. And for these fractions, across is easier. We all know the square root of 81 is, and we all know the square root of 4 is. And hey, that's a 9/2. That's a 9/2. By the way, do we want mixed numbers? No, that's the baby way. All right, elementary does mixed numbers. We leave fractions. Okay. So just leave it as an improper fraction. That's good to go. And we got 9/2. All right, so go ahead and do B. Apply the rule. Do what you can. Go ahead and do B. Do B. All right, hopefully you know your 13's times tables. If not, you punch it in your calculator, because 13 squared is 169. And hopefully we all know 100 squared is 10, 13/10, right? Pretty easy. All right, let me give you one more here that's not on your thing. Let's do a C over here. Uh-oh, no color. We're surely going to be in trouble now. No color. Go ahead and do this one. Square root. Oh, hold on a second. Don't write that. I'm backwards. Square root of 5 over 16. Go ahead and do that one. Square root of 5/16. Oh no, there's no color. I don't know what to do. No earthly idea. Math's so hard. Andrew's already done. Kyle's done. Blake's done. Gabe's done. Wyatt's done. Madison's done. Those like coins, Madison? That's not real gold, is it? Oh man, that would be, you know how valuable that would be if that was gold? Each one of those coins would be about an ounce of gold, so that'd be like $1,200 a coin. That'd be valuable. It'd be awesome. Doesn't Madison look like a Greek goddess or something? I mean, it's coins. I don't know. That coin thing works. All right, so you just said, hey, it's the square root of the top over the square root of the bottom. So you all put a 4 on the bottom. What'd you put on the top? Oh, round offs. We don't want round offs. Just leave the square root of 5 up there. That's all. Don't give that decimal round off stuff. Leave it exact. All right, leave it exact. Don't round that thing off. All right, does that make sense? Right? Makes sense, though? Okay. All right, last thing. Last thing. Sometimes you can reduce. Look at this. If you put them back together first. What? What? Yeah, sometimes it helps to go backwards. I'm just telling you. Sometimes it helps. Look at this one. Can you simplify the square root of 10? Yes or no? Yes. No, you can't. Decimal round off is the only way. A 10 is a 2 times 5. Can you simplify the square root of 2? No. But you know what? What if I go backwards? What if I put them back into a fraction? Can you reduce 10 divided by 2? Yeah. Look at that. We end up with the square root of 5. So it was to our advantage to go backwards, because we could reduce that fraction. Okay, you might say, I would have never thought of that. Yeah, I know. That's why I'm showing it to you, right? You say, I would have never thought to do that. I know. But now it's in our notes. And so you would have never thought to do it, but how about doing it on 2? Go ahead and do 2. See if you can take it all the way as far as you can go with it as an exact answer, no decimal round-offs, all right? See what you can do with 2. How come 1 didn't have its parentheses? It feels so bad. I need a parentheses too. Okay, thank you. get it right. It's the grand finale. You got to finish with a flurry. A flurry. How about a McFlurry? Sounds good. You guys ate lunch already. I haven't eaten lunch yet. Although you guys did get me out of outside duty. My first 5 years here, I had lunchtime outside duty with the senior high for lunch. That was my duty. So I had to be outside every single day at lunch. Rain, sleet, snow, hail, or gloom of night. I was out there. And when I first came, who was it? Tiffany. I can't remember her last name. She had like a record that all through her high school year, she like every time, maybe except one, she ate outside. Didn't matter if it snowed, rained, or whatever. So you guys got me out of outside duty. So did you put it together? I mean, that's what we just learned, isn't it? Oh, this should be green there. That if you put it together, you might be able to reduce it. All right, 15, 3 times 5. 20, 4 times 5. Oh, the 5s are gone. Did you split it back up? Why not? By the way, the radical police say they will issue a citation if you leave a fraction as the radicand. Shame on you. Okay, you can't leave a fraction as radicand. But look, can't we do something with this? Isn't the square root of 4 2? Anybody get square root of 3 over 2? Ah, look at that. Oh, look at that. You're only 3 of you. Should feel good. You got it, and everybody else didn't. What happened to the rest of you guys? Would you stop at square root of 3/4? Didn't you see that 4 sitting there waiting for you to do something with it? All right, well, now you know radical police will issue you a citation. Quiet, please. If you leave a fraction in the denominator, Ashton, right? But you didn't hear that, did you? Because you were interacting with Connor. So quiet. So that's the lesson. As you see, the homework's at the bottom, but this homework, and you can cry all you want and bellyache all you want, but we've had too many snow days. This isn't due tomorrow, though. This is due on Monday. Nothing we're doing today, though, is going to be on tomorrow's quiz. But anything we've done so far this chapter will be on tomorrow's quiz. This homework is due Monday for everyone. Be careful. It's not due until then, so you can tend to forget about it, but it's due Monday. You say, we deserve 4 days off with nothing to do. Give me a break. You've had tons of days off with nothing to do. Do your homework, all right? Don't bellyache about it. Bellyacher. Bellyacher. Now, it's good for you. Do your homework, but not due until Monday.